Welcome to today's Explainer. I know we've all been hearing the term AI thrown around constantly lately, whether it's in the news, on social media, or at work. And honestly, I really wanted to understand what's actually happening behind the scenes. So today, we're going to unbox it together, step by step. By the time we wrap up, we'll get past all the jargon and buzzwords and see exactly how this whole ecosystem fits together.
Now, if AI sounds a little intimidating, the reality is you are almost certainly an AI power user already. Seriously, if you unlocked your phone today with Face ID or asked Siri or Alexa for the weather, you interacted with computer vision and speech recognition. When Netflix magically knows your next binge watch or Amazon suggests that perfect purchase, yep, that's AI. When Google Maps accurately predicts your arrival time despite insane traffic, or when developers use GitHub Copilot to write software faster, that's AI at work. It's not some distant science fiction. It's the invisible layer of convenience powering our daily lives. To understand how it works, think of AI like a set of Russian nesting dolls. We're going to start with the biggest, outermost doll and slowly open it up to reveal the tech that's making headlines today.
Here's our quick roadmap for today. First, what is artificial intelligence? Second, the core principles of machine learning. Third, the 3 types of ML. Fourth, deep learning and neural networks. And finally, Gen AI, NLP, and vision.
Let's kick things off with Section 1. What is artificial intelligence?
The absolute simplest definition is that AI is technology allowing computers to perform tasks that normally require human intelligence. We humans are naturally great at pattern recognition. Like, if I tell you an input of 2 gives 4, 3 gives 9, and 4 gives 16, your brain quickly spots the pattern, right? It's squaring the number. So if I ask what 5 gives, you instantly know it's 25. AI is simply giving a machine that exact same ability to look at data, find the pattern, or even understand the subtle context and emotion in human speech, just like we do when we're talking to a voice assistant.
Moving right along to Section 2, Core Principles of Machine Learning.
Opening up that first nesting doll, the vast majority of AI we interact with today is actually machine learning, or ML for short. Instead of humans painstakingly typing out endless lists of strict, rigid rules, these algorithms learn directly from massive amounts of data. This whole field absolutely exploded over the last couple of decades for one simple reason. The internet gave companies a gigantic treasure trove of data to learn from.
What I found really mind-blowing here is the complete paradigm shift in computer science. In traditional programming, a human gives the computer the data, which is the input, and the rules, which is the logic. The computer then calculates the output. But machine learning completely flips this on its head. We give the machine the inputs and the desired outputs, and the machine figures out the underlying logic all by itself. It's literally building its own rules.
To make this super concrete, let's look at a bank loan analogy. The ML process happens in 2 very logical steps. Step 1 is training. The bank feeds the algorithm thousands of past loan applications, so inputs like salary and credit score, along with the outputs, meaning whether those loans were actually approved or rejected. The machine studies this and builds a logic model. Then step 2 is inference. A brand new customer walks into the bank. We feed their fresh details into the model, and it infers or predicts whether they should be approved based entirely on the historical patterns it learned.
Which brings us to Section 3, the 3 types of machine learning. Method number 1 is supervised learning. The absolute crucial point here is that this uses labeled data. It's kind of like a teacher showing a student flashcards with the answers printed right there on the back. We use this for 2 main things. First is classification, which is sorting things into fixed categories. Think about Gmail automatically labeling an incoming message as spam or not spam. Second is regression, which is all about predicting a fluid numerical value. When your food delivery app predicts your burrito is going to arrive in exactly 43 minutes, and hopefully it's still warm, that is a regression model hard at work.
Method 2 is unsupervised learning. Here, there's no teacher, and the data has 0 labels. We just hand the AI a massive pile of raw data and basically say, hey, find a pattern. It turns out it's incredibly good at clustering. If you give it a million totally random news articles, it will naturally group them into distinct clusters like tech, politics, or sports, based on related keywords. This is also absolutely vital in cybersecurity and finance. By knowing what normal data clusters look like, the system can instantly spot anomalies, like, say, someone suddenly logging into your credit card account from 5 different countries in the span of 1 minute.
The third method is reinforcement learning. Think of this one exactly like training a pet. When you tell your dog to sit and it sits, you give it a treat, right? If it misbehaves, it gets nothing or maybe a firm no. In this type of ML, the AI agent operates in a digital environment where it receives mathematical rewards for good actions and penalties for bad ones. Its singular goal is to maximize its total reward score. This trial and error approach is exactly how AI learns to master incredibly complex, skill-based games like chess or Go, and it's heavily used to teach self-driving cars how to navigate our roads safely.
Let's dive deeper with Section 4, Deep Learning and Neural Networks.
So traditional machine learning is great, but it really struggles if you just feed it raw video, images, or complex audio. For that kind of messy, unstructured data, we need deep learning. This is a specialized subset of ML that uses artificial neural networks. These are complex digital networks deeply inspired by the physical neurons firing in our own human brains. And honestly, it is astonishing to see how good they are at extracting meaning from raw, messy data without a human having to constantly hold the system's hand.
Let's look at how a neural network mathematically thinks. Imagine a college calculating a student's final grade, their CGPA. At first, maybe class tests don't count for much, so students just skip class. The teachers notice this, so they adjust the weight of class tests to be higher, say 30%, to force a better outcome. In this case, higher attendance. Neural networks do the exact same thing mathematically. They take in various inputs and assign a specific mathematical weight to each one. Through relentless trial and error, they constantly tweak and adjust these weights to arrive at the most accurate possible final prediction.
And this brilliant adjustment process happens in a continuous loop of 3 distinct steps. First is forward propagation. The network takes an input, processes it through its current weights, and makes its best guess. Second is loss calculation. It checks the correct answer and calculates exactly how wrong its guess was. That error is called the loss. Finally, backward propagation. It literally goes backwards through the network, tweaking and adjusting every single weight so that the next time it makes a guess, it'll be just a tiny bit more accurate. It does this millions, sometimes billions of times until the network is highly trained.
Finally, we reach Section 5, Gen AI, NLP, and Vision.
Up until this point, we've basically talked about AI predicting things or classifying things. Generative AI, or Gen AI, takes a massive leap forward. Instead of just organizing existing data, it actually generates entirely brand new content from scratch.
It's honestly wild to see all these famous tools when you break them down by domain. You're probably already familiar with text generators like OpenAI's ChatGPT, Google's Gemini, or Claude. But Gen AI spans pretty much every creative domain now. Midjourney and DALL-E are conjuring up stunning, award-winning images from just simple text prompts. Tools like 11 Labs are generating incredibly lifelike audio and voices. And GitHub Copilot is writing entirely new lines of complex software code for programmers, saving them hours of work.
Now, to make a tool like ChatGPT actually work, you need natural language processing, or NLP. This is the science of teaching a machine to interpret human language. Modern NLP relies heavily on large language models, known as LLMs. These are built on a specific, highly advanced neural network architecture called a transformer. Transformers are totally revolutionary because they don't just read words one by one sequentially. They use a mathematical attention mechanism to look at an entire sentence all at once. This allows them to grasp the deep context and meaning behind the words, just like we do in normal conversation.
And what about visual data? Well, that's computer vision, the literal eyes of AI. Because computers obviously don't have human eyeballs, they use specific networks called convolutional neural networks, or CNNs. A CNN looks at a photo not as a picture, but as a massive grid of numbers representing individual pixels. By analyzing clusters of these pixels, it recognizes edges, then shapes, and eventually full, complex objects. This is exactly the technology used by automated traffic cameras to instantly read a fast-moving license plate and issue a traffic ticket without a human ever looking at the footage.
And just like that, we have unboxed the layers of AI together. From basic pattern recognition to neural networks acting like the human brain, all the way to machines that can literally generate art and code out of thin air. It really feels like we're finally speaking the language of the future. So, I want to leave you with a quick thought to reflect on. Out of everything we covered today, which part of the AI ecosystem did you find the most fascinating? Thank you so much for joining me on this explainer, and keep exploring.